Okay. So we have Pyotr Kolechkovsky joining us today. It's like, I hope I did okay with the name. He's going to talk about the CQL not operator. I think if you looked at it, it's a new feature that would implement new not CQL operators into Cassandra and make it much more queryable. So he's going to walk through what that looks like, and then we'll have some questions at the end. If you have questions throughout, just put them in the chat window, and then we'll ask a few questions at the end about how to participate and that kind of thing. But Pyotr, the floor is yours.
Okay, thank you. Yeah, let me share my screen. Unfortunately, this is turned off. I cannot share screen.
Oh, sorry about that. Let me change that.
It says that host didn't allow me to.
Patrick says, I am not looking forward to this. Okay, there you go. Excellent.
Okay. Can you see the screen, the title slide? Okay, cool. Yeah, so this will be short presentation. I got a few slides, but I also have a live demo planned because I think that this is the better way to actually show how the feature works interactively. So because this is kind of alpha feature still, so expect surprises. And
if you're expecting
anyway,
to show slides, your screen is blank right now.
My screen is blank.
I see. I don't see anything.
I see his slide.
I see the title slide.
All right, let me make this a me problem then. Carry
Patrick,
on.
you need to get your desktop game together.
Aaron, shots fired. Okay, I know where you live.
Is everything fine now? Almost everybody.
It's just me, Pyotr. So just keep going. Okay. I'm sorry.
Okay, no problem. Yeah. By the way, this is my first CP. And I must say that this was really, really fun for me to actually code it, and like getting it from the right, from just specifying the CP document and working on the design and then implementing and then testing and then getting the reviews. That was very exciting, and I hope to get more of that experience in the future. Okay, so the main motivation for the not operator is that, I like symmetry. I realized that in Cassandra query engine, in CQL, we have some operators which can be negated. Like if you query for less than, you can also easily query for greater equals, right? I mean, some operators have their negated counterparts and they work perfectly. But for some other operators, you can only do positive queries. Like you can ask for something equals something, but you don't have not equals. Or there is like in operator, but without not in, contains, not contains. So I wanted to have symmetry and add the negated operators. I know that they are probably not as useful as the positive ones. However, often if you really need a negated operator, then the only choice you have in Cassandra until now is to just filter on the application side. So you have to query all the things and then filter out the things that you don't need. So this is not only going to make CQL a bit more flexible, but also sometimes you should gain a bit of performance with those operators, because the filtering or even the lookup with help of secondary indexes can be faster when it's natively handled by Cassandra. Okay, so a few motivating examples, what you are able to do with this feature. You can just use not equals on the clustering column, like in the first example. You can mix not equals with range queries on the clustering column, like there's merging that works on them. I'll show later how it's achieved. There is not in operator, which works very similarly like in operator. I mean, the same syntax is accepted here. And not in also works with range queries. So you can restrict a single column with both not in and range predicates with range restrictions. It works for multi-column restrictions as well. So you can specify multiple clustering columns in a single not in clause, like in the fifth example. And then there is a set of not contains operator that works for collections, lists, sets, maps, map keys, map values, and map entries. So you can ask for rows with collection that doesn't contain some element, or with a map that doesn't contain some key, or even check if the value under given key of the map is not equals to some value given in the query. Also, those not contains and not contains can be merged together. So like in the last example, in ninth, you can see that we can query for map contains given key, and also the value under that key is different than some value. So this should be fairly flexible. However, there are some limitations and some non-goals. I wanted initially to keep it simple. So we decided to not implement the general not operator that you can put anywhere. So like we don't have arbitrary nesting yet. That might come in the future in the separate CEP. Some queries would still require allow filtering because technically it's not possible to evaluate them without filtering in the storage engine. So that's why, for example, if you use not in on partition key, then allow filtering will be required. Also, without secondary indexes, traditional rules apply. Like if you query on non-indexed column, of course, allow filtering would be needed as well. But this is the same for the in operator. Then it was quite a funny situation when I wrote the CEP. Initially, we said that, okay, we want to support updates and deletes. And then after I implemented, I remember I got some question from Benjamin. Hey, but did you test updates and deletes? Could you write some tests for that? Okay, yes, I put some tests for updates and deletes. Of course, the test expectations were that those tests would fail because that thing is not supported. And then I realized that one of the tests is actually failing because deletes work fine. There's no problem with deletes. So this feature, kind of, I got it for free. So I implemented not in for clusterings, and deletes just work. Updates don't cover range queries, slice predicates. So because of that, not in is also not supported. So that's left for future work. There is one more thing related to indexing support. So you need indexing support for using not contains without filtering. I implemented that for storage attached indexes. A similar story is required for implementing not like. However, with not like, we don't even support like, I mean, the positive operator in storage attached indexes. I know that this is supported in SASE. And it's also not supported in allow filtering. So like to me looks like it's not implemented fully, even on the positive side. So for now, I didn't implement not like operator. This is up for discussion, whether we should wait and hold on the feature until we have full not like support, or maybe it's fine to just merge it without not like and postpone it to future CEPs. Okay, let's do the demo. Oops, that's yeah. Now you should see my console. There is CQL SH running. I got also Cassandra already started in background. So I got a table prepared for you already.
Piotr, can you make that any bigger by chance?
Yeah, more bigger. Okay, yeah. Sure. Let me do that even bigger. But is it big enough or even bigger?
That's pretty good. Yeah,
that's good. Okay, yeah. I don't know how it looks on the other end of Zoom. So
yeah.
Okay, I hope now it's good. So okay, I got a table with just two clustering columns. Primary key, so partition key, we don't care, it's a single partition because all that stuff that I want to demonstrate on that table works within the single partition. So I want to demonstrate how not in works. So I can select from this table where, okay, partition key, I need to specify one. So like if I, whoops. Okay, if I do it like that, okay, I get a full table. Now I can specify, for example, where C1 in, let's say, in B. That's without not. So I just selected the middle of the partition, just the entries with B. So now let's invert that. Not in B. So I get A and C. So it's working. It doesn't require allow filtering because it transforms not in into a list of slices. So it actually selects two slices. So everything up to B and everything greater than B. And then concatenates the results. Okay, let's try something slightly more complex. Of course, we can specify multiple things here. So if I exclude B and C, then I get only A. And I can also do, I can merge them with branch slices. So for example, let's exclude B, and let's say that C1 is greater than, for example, A. So then I should get only C. And it works. We can also do multi-column clustering clauses. So for example, I can say C1, C2, not in, and let's exclude, for example, let's exclude B and 2. And we can see that, yeah, we excluded one row here, so we don't have the combination 0B2 is missing from the result set, and the whole table beside that is present. So it works as it should. Do you have any questions related to this particular feature? No more questions? Okay, let's move on to not contains. So for not contains, we need some collections, some sets. So I got two tables. I got a table which I just call sets. I got a few sets here. And similarly to how I did that before, let's first try the positive query. So where S contains, for example, number 2. Allow filtering here because this is non-indexed. Okay, so here are the 3 rows. Oh, 3 rows contain 2. Okay, good. So where S not contains 2, so I should get the other row. Okay, yeah. So you can see that those results are complementary. Together they form a full table. Actually, I can merge multiple not contains in a single query. So I can, for example, say where S contains 2, contains 2, and S not contains 1, maybe. Yeah, so we got a row that contains 2 and doesn't contain 1. If I just ask for not contains 1, oh yeah, so this brings more. But the other one, so the row with primary key equals 3, it doesn't have value 2. So that's why it was excluded with the previous query. Okay. The same thing I can do with the maps. Typo. And here I inserted one empty map. This works on empty maps as well. Empty maps are indistinguishable from nulls in Cassandra world. But that was, by the way, tricky use case to get right. Because null values or empty sets, empty maps, they don't get inserted into the index at all, and they don't. Okay, that was tricky for indexing. Okay, I'm going too much forward. But anyway, it works with nulls. Just you have to trust me. Okay, let's try query select from maps where, for example, map M contains key 1. I think I get 2. Oops, allow filtering. Yeah, I got 2 rows, and where M not contains key 1, I got the other 2, and you can see also that null got returned. Because null, of course, doesn't contain key 1. Here I can also join multiple ones, multiple different types of not contains, or contains and not contains can be mixed together. So for example, let's just leave the row with value B, and M contains B. Yeah, the query passed. So this is all with allow filtering, but allow filtering, as we know, it has some sometimes bad performance characteristics, because it has to go through all the rows and check each collection if it contains or not contains the item. So it can be accelerated by indexing. So I can create custom index on, for example, on maps, and let's index values.
And Piotr, we have one question.
Yep.
When you can you do not contains key 1 and not contains null?
And not contains null. That's a good question. I haven't tried with null. Okay, let's try this in a moment. Okay, so where not contains null, unsupported null value for column M. So I think that this doesn't support, it doesn't support at the at the restriction level. So like when it gets the values from the parser, at the moment it doesn't handle nulls. But okay, that's a great question. I'll take a look at that. Maybe it's possible to actually implement it properly, because that looks like an omission. By the way, does it actually support if I just say M contains null? But this is not supported even by the positive operator. So I mean, my way of working here was just to make negative operators accept the same stuff as positive ones. So like if contains doesn't support nulls, then not contains probably also should work the same way. However, I wonder why it's that. I mean, M contains null, maybe. Oh, but it's not like M contains null. It's like actually the whole column M is null, like the whole collection. So it was like asking if M is empty. I don't know. Okay, that's a good question anyway. I have to think about it. Okay, so now we indexed the values of M. So I think that we can just do something where M not contains B, and I can get rid of allow filtering. Yeah, so now you can see that it works probably also. Yeah, for keys, we still don't have the index, so I need to create index on keys. And now this query also works. Yeah, so this is all I had to show in the CQL SH. I have one more thing to demonstrate, And this is the performance of indexing, how indexes actually affect not contains performance. So I got a workload. Oh, I need to make it bigger again. So this is, don't worry. It's a workload definition file with which would basically create a table, create an index on one of the columns. So it would create a table with two columns. One column contains a set of values and it's not indexed. And the second column also contains exactly the same set of values, but will be indexed with storage attached index. And then we will run some inserts on it and then some reads, looking up values that don't contain some item. Yeah, and let me quickly run the benchmark. Let's first create a schema. Okay, we got a schema. Let me show you how the schema actually looks in CQL. There is table CEP-29. Describe CEP-29. So yeah, the table is just ID and two sets with text, and V2 is indexed, V1 is not indexed. The table is of course empty at the moment. Yeah, nothing in there. Let's load some data. That will take a while. So each set that I'm inserting now has 100 items. So it's 100K rows multiplied by 100 values in each set, but sets have random content. And sets are created in such a way that there's always some item missing in there. So now I can run some queries. First with filtering. No query, let's run. Okay, I won't run it until the end, but I can see that there is something like 400 requests per second. And now without filtering, so that would be just the default query. And we can see that it is way faster. It's 3,000 requests per second. Overall, actually over 4,000 requests per second. So there is actually a pretty large difference. Of course, this benchmark is kind of optimistic for this kind of workload because we got big sets and each query actually skips a lot of rows. So it actually tests that skipping rows with the index is much faster than fetching all the rows into memory and then checking if the set contains a given value. Okay, so that's it about the demo. Any questions?
Anybody else have other questions for Piotr? More QA you want to do live?
Okay, we can always go back to it. I mean, I got this shell open still, so yeah. So the last few slides I had prepared about like how I actually implemented that. So like how it's done inside. And my idea was to actually split it into separate sub features that are not overlapping. So the first idea was, yeah, let's get everything working with allow filtering and don't care too much about performance. Then the next step was, yeah, let's implement the not in operator on the clustering columns. It touched only the clusterings, and that was kind of like separate part of the Cassandra code to touch, so it didn't overlap with the other features. And then the last thing was, after I had not contains working with allow filtering, the last step was accelerating it with secondary indexes, which turned out actually to be the most complex one. So it actually required a lot of changes in the storage attached indexes code, which was, by the way, introduced by CEP-7 as far as I remember. Okay, so initially when I approached the code, after creating CEP, I had not much idea of like where things are in Cassandra codebase. Actually, the query parser and the query execution part is something that I have never touched before. So my way of working was, okay, obviously where the query starts is somewhere in the parser, right? The parser is the first thing to invoke on the query to just create some abstract syntax tree from the query. So let's add the not operator support there. For that, I had to create special variants for not in, not contains, and not contains key operators in the operator enum. And after adding that to the enum and then adding proper productions into parser, which were actually mostly copy paste of the positive operators, and then just adding not keyword in front of the operators. Then I just simply compiled it and ran it and tried running the queries with not operators. Of course, I knew that it will crash. And I just observed the exceptions I got. So like it, of course, complained that it cannot support not contains or not in some place, or sometimes it didn't complain, but actually returned incorrect result set. So then with every failure I got, I just looked at, okay, what could be the direct reason, learned that code, fixed it, and then retried, and then of course it would break a few steps further until it's all worked. So eventually I got to the bottom of the query processing pipeline, and this way I made all operators working. So it ended up with modified parser with new operator variants. But also not contains required some changes in the contains restriction. That was actually easy to find. Like, okay, we need to implement not contains, so maybe there's something that already handles contains. Yeah, there's contains restriction, good name. So I found it. My initial idea of implementing that was, okay, I just copy the contains restriction, rename it to not contains restriction, and then implement it accordingly, like revert the logic inside. So put negation in various places so that it works. And that kind of worked. But then I realized that this way I cannot have both contains and not contains in the same query, because you cannot merge restrictions of different types for the same column in Cassandra. That's a limitation of how things are architected at the moment. So I had to revert that design, and eventually I implemented not contains as a special case for contains restriction. So contains restriction contains new fields for negative values, keys, and entries. Let me actually show it in the code. Maybe that would be more understandable.
And while you're doing that, Piotr, just to note, we're at the end of our time, so I want to make sure.
Okay. Yeah, so maybe let's go high level. Okay, yeah. So not in was created with implemented as a slice restriction. Again, so my initial idea, yeah, let's take the in operator and let's negate that and create a not in operator, not in restriction. But this also was a wrong way to do that. And at the end, I created that logic. I put that logic into the existing slice restriction. And this way we can merge not in with all the other slice operators. So less than, greater than, etc. Not like hasn't been implemented yet, so let's not talk about it. Okay, very, very shortly. When I modified code, I also tried to simplify something. So like when I noticed that there was something that was overly complex, I simplified, for example, I simplified multi-clustering builder. now it actually has more features. And at the same time, it's 33% shorter in terms of lines of code, and also added a lot of documentation. I mean, when I try to understand how things work, I actually put some notes, put some comments to make it easier for the next people who would work on this code so they can ramp up faster. Yeah, I also simplified the in restriction, by the way, even though the logic remained the same, now there's no inheritance there. The code got also shorter by introducing some abstractions. Yeah, okay. And basically, the last thing I wanted to explain was how we make those queries with storage attached indexes. So the essential part of that was anti-join operator. So the operator that takes two iterators and returns the items that don't match on the other iterator. So it returns all the items from the first iterator that don't match on the second iterator. The iterators are, of course, sorted by keys. And then we do those anti-joins per each index, per each mem table or SS table that we have. And afterwards, we, of course, concatenate all the things together as usual and get the final result set. Because of those anti-joins, not contains is not as fast as the contains operator, but it still should be faster than filtering most of the time. Okay, thank you. That's basically it. I mean, there are a few things left for implementing, and I'm open, for discussion and questions. Happy to address concerns. And
there's one question from Vikas in the chat. So going back to one example, select from KV where PK equals 0. You can probably, can you see it in there? I can read it aloud, but it might be easier to.
Yeah, I need to figure out how to load the chat in this weird mode when there's screen sharing. Oh, here it is. Okay, I think I found it. Yeah, that's right. So so B was for one column and 2 was for C2.
Okay, good. Sounds like that answered the question.
Yeah.
Okay, great. And I know, Piotr, was this intended to be in 5.0?
No, okay. Initially, maybe at the beginning when we wrote the CP, yes, but then after implementing that, it caused a bit of a delay, and because of other things that also were needed, and eventually it slipped past the freeze, and yeah, it's intended for the next release.
Awesome. Okay, great. And if someone wants to contribute or help in some way, what's the best way to go about that?
Probably reviewing the code at the moment. I got 2 reviews, which were great. By the way, one of the reviewers found a real bug in it. But yeah, basically reviewing the code, especially focusing on things that might be missing, because I'm not an expert on the whole Cassandra code base. So already a lot of people told me that, hey, but did you think about, CQL shell autocomplete? Oh, we got CQL shell autocomplete. Oh, yes, definitely. I should have thought about it. So, things like that. Because probably the things that already there kind of works, because, I mean, it's covered by unit and integration tests a lot, but there might be still missing things, like this null question today. Like, have you thought about what happens if you put null here?
Awesome. Okay, great. Well, I put the Jira ticket. I don't know if that's the right one, but the Jira ticket that it looked like it was in the CEP in there.
Yeah, it is.
Look. Okay, does anyone else have questions for Piotr? If not, you know where to find him. He's on the ASF Slack. Thanks for joining. Just wanted to remind people we do have this meeting monthly. The next one is November 28th, same time. This is an open one. We're looking for someone who wants to share something, like if you're working on a CP, you want to discuss other ways for people to contribute to the community, just get in touch with me and we can, or you can just get onto the wiki and add your name to the schedule. And then November 30th, that week, we have our town hall that has Monday DB is presenting about building their in-house data engine using with Cassandra. And then Josh McKenzie is doing a state of the Cassandra developer community. So I'm going to put a link in here for both of those. Yeah, and thanks, Piotr. Really appreciate the time. And thanks to everybody for joining.
Thank you very much.
All right.
Thanks, everyone. Thanks, Piotr.
Thank you.
Nice job.
Great day, everybody.